Hello everybody, hope you're doing well. My name is Mahmoud Jasri and welcome to the new chapter, which is going to be the continuous part of previous chapter related to polynomial. So today at this point we are going to talk about the new topic which is related to rational world, and it would be about the blueprint for a new class of functions. So if you guys remember, for the previous sections we were talking about the polynomials, how we can some kind of solve them, and very first and common polynomial was a quadratic function. We talked about it, how we can draw it. Also in the previous chapters we talked about how we can visualize them to make sure we don't have any problem with the domain especially. So at this point we are going to see that what would happen if we combine them into the rational form, or most commonly in the fraction mode. So we have to see what would happen there. We are going to solve a couple of equations and also talk about inequalities, and most important part about some kind of problems and flaws that we do have when we are trying to solve them. So without further ado, let's just talk about it. So the first part of the work would be about the introduction. The introduction section would be about how we are going to deal with this polynomial. And this polynomial or rational expression means that you do have a polynomial on the top like this one, and you do have another one on the bottom, and we are going to talk about them. So this is the function form that we have. If you guys remember, the f of x, or the function that we have most of the time, was related to the x to the power n, or whatever, some kind of degrees that we have. But right now my f of x is going to be combination of polynomial. It means that on the top, or the numerator, I do have the polynomial, and on the denominator I do have the polynomial itself. So my f of x is going to be px, one polynomial on the top, and the qx on the top. Where we see this kind of things, because obviously the behavior of the first one and the behavior of the second one would be different. Like the speed, I do have a distance that follows the polynomial. I do have a time that follows the polynomial. About the density, I do have mass over volume. About the average cost, about the total cost over the item that's going to be produced itself, and we are going to see what would happen. The very first and important thing about all of the fractions as we had before is we have to know a fact, and that fact is that there is no 1 over 0. It means that you cannot have a condition that your denominator becomes something this like the 0 itself. Why? Because we would face a problem, or we call it as undefined. 1 over 0, or whatever value over 0, for example x to the power 2 over 0, whatever, we have to somehow prohibit that thing to happen. So it is very important for us to just, before solve an example, any kind of power polynomial or rational or fraction section, it is very important to us to make sure we don't have any number, we don't have any domain that's going to cause us that problem. So it is very important to, at the beginning of the point, try to put everything that causes problem aside, like this one. So it means that right now, the very first important and unbreakable law about the denominator is that the denominator, the qx, whatever one is the denominator, can never equals to 0. Again, why? Because that thing is going to lead us to undefined. So it is very important to, when we consider or when we talk about the domain, should be a rational function is all of the real numbers except the values that is going to make the denominator 0. How we can do that? Simple. Makes the denominator as 0 and find whatever values as x there. So at the end of the day, when you, for instance, had an equation of fractions, and even you found that x as one of your numbers, you have to compare that one to your prohibited one to make sure your final answer is not going to be in your prohibited section. Because yes, it could be the final answer, but it also could lead you to a fact that is going to face to 0 over 0, which is still undefined. So we can see a very simple example over here, x plus 3 over x minus 2. It means that this function can have anything rather than x is equals to itself, because it's going to make this part as 0. Also, for another function, I do have x to the power 2 subtracted by 9. If you solve this guy, it's going to be a difference of perfect squares. Or for some of you, if you are very familiar with x2 plus bx plus c, you know that x1 is negative b plus delta, square root of delta over 2a, and x2 is negative b subtracted by square root of delta over 2a. By finding these two numbers or these two roots, I can write it down like this. It means that 3 and negative 3 are going to be my answer. So I have to make sure at the end of the day, I should not consider these two guys as my final value, which is going to cause us some problem. So at some point, you do have some kind of polynomial over polynomial, and the situation is a little bit complex. And you see, I can make it better, or I can simplify it. So that's why we do have this simplification. At some point, after doing the factoring, by the way, what was factoring? Factoring means that you can write down your function or your polynomial function, whatever is that, into the small chunks that if you multiply all of those small chunks together, you still have your final value is your polynomial function. So sometimes you see that I can make the numerator a little bit simpler by just writing down as fraction. In the same time, I can do the same thing with my denominator, but I can see that some of the terms on the top and some of the terms on the bottom are the same. So it means that I can cancel them out. So this is the whole idea of simplification. It's just like the fact that you are trying to combine the like terms. If you remember from the previous parts, if you have an x, you can combine them, it would be 3x. But at this point, you have fraction. You can cancel them out. It's something like that you have 2 divided by 2. And at the end of the day, you can cancel them out, or you can write them as the way it was. But we prefer to simplify them as much as possible. So look at this one. This is the strategy. First of all, we have to factor completely. It means that we have to factor and denominator. For instance, if I do have x to the power 2 plus 2x, I know for a fact that x is common between these two. So I have x times x plus 2, and this is called factoring. Then I have to identify the restrictions. Remember about the last law. I have to find the points that if I put numbers there, I'm going to have undefined. For instance, if I do have something like this, I know for a fact that x is equal to 3 is going to be my undefined. This is a very important part because some of you is going to simplify everything, and at the end are you going to find the restrictions. No, you have to do it beforehand, because yes, your final answer is going to be a simplified one, but yet that simplified answer came from something. So I still have to look for that something, or I still have to look for that restrictions. So it is a very important step. This should be step number 2, not the last step. Remember that. At the end, I have to cancel the common factors, which is going to actually do same thing that we did before. So I do have x to the power 2 subtracted by 9 based on the previous slide is x minus 3 and x plus 3. For some of you that are a little bit curious about that, it is a difference of perfect squares. It means that wherever you see x to the power 2 subtracted by a to the power 2, the first one was a perfect square, the second one was a perfect square, you can write it down like this. I believe you know better than me how we can prove it, but just keep it that way. So I do have this one on the top, and I do have apparently, as I just told you, the one x is common, x times x minus 3. Is that okay? So I do have this. Remember about the second step. Second step is that I have to find the restrictions. So since this guy is on denominator, I have to make sure, let me just use another color for you. I have to make sure that I'm not going to use x as 0. I'm not going to x as 3, even if I do have the final value for my numbers or final values in an equation, and I still find those numbers, I can't use them. So x cannot be equal to 0 and 3. This is my restriction. After that, I do have something like this, right? And I see that x minus 3 and x minus 3 are repetitive because they have it on the top and they have it on the bottom. So I can cancel them out. And at the end, it is my simplified form. Again, remember, the simplified form is x plus 3 over x. That is going to hide the fact that its original restrictions are going to be hidden over here. But we know from the second step, since we did it beforehand, and since we did it as soon as possible, we considered 0 and 3 as restricted ones. So let's talk about a very common mistake that I saw so many students did that one, and was about the cancellation. Guys, remember, you only can do the cancellation on the numerator and denominator on a time that you have multiplication. It means that when your x is on the top and another x is at the bottom, they should be in factors. You cannot have a condition that you have adding or subtracting on the top or bottom, and after that try to cancel them. No, it's completely against the rules. Why? Because at the end of the day, if you have the simplified form, your simplified form is going to be different with your original form. So let's see some examples over here. Imagine that I do have x2 plus 4x, and its is going to be divided by x. So based on the factoring, I'm going to factor this one. X times x plus 4. What does that mean? It means that if I just multiply this guy by this and this one by this, I'm still going to have x2 plus 4x. I just have the x as itself, right? So the very some kind of logical way is just cancel the x and x plus 4 by knowing the fact that I know the x cannot be 0 itself because I do have this one as restriction. But something could happen and leads you to this fact that x plus x2 is to the power 2 plus 4 divided by x, and you see that x apparently is common, so I can just cancel one of this x and write it as what? X plus 4. It's completely forbidden. You cannot do that. Why? Because this, first of all, you do have addition, and this kind of x should also be here as well. So if you don't have any x beside your second number while you have the addition, it is completely forbidden. And also what would happen over here? The same thing. 3 can cancel 3 and I do have x. I saw it tons of times, people. Try to be very careful because at the end of the day, you are going to lose mark. So another kind of problem would be over here, 2x plus 6 divided by 2, and we said we can cancel out 2 and this. No, it's not going to happen. One thing that you can do is to factor the 2 in the top, and you have it on the bottom. Right now you can do that. So x plus 3 is going to be your final answer itself. So what about the multiplication and division of some kind of the rational form or the polynomial form? So it is just like the way that we did before with the numbers. If you guys remember, for example, if you have 2 over 3 times 4 over 5, you have only the thing that you have to do, multiply the numerator together and multiply the denominator together, and you have your final answer. But at this point, since we are talking about the simplification, it would be better to do it beforehand. It means that first of all, you have to factor everything. Then when you're multiplying, you can have a solution to make it simplified just beforehand. If you see one term is going to be common in the first numerator and the second denominator, you still can cancel them out, right? Because at the end of the day, they are going to be the same. They are going to be inside the same fraction. So let's look at this example that you could some kind of clear your mind. Imagine that I do have x plus 1 over x minus 2, and I do have on another side x times x minus 2 divided by x plus 1 to the power 2. So you can see that either I can do all of this multiplication at the beginning, multiply everything together, so I do have x times x plus 1 times x minus 2. And after I do this multiplication, it would be x minus 2 times x plus 1 to the power 2. And then do the simplification, or I can do the simplification at the beginning. How? X plus 1 is a common term like this one. So I can say that I can cancel one of these ones with this one. X minus 2 is also going to be common with this x minus 2. I can cancel them out. So at the end of the day, I do have x divided by x plus 1. Guys, remember, after doing this simplification, we still have to make sure we follow the restriction rule. So it means that right now, yes, some kind of denominator is going to be -1, and -1 is restricted. Yet, from the very beginning of the part, I still have another one as x minus 2. It means that my restriction, rather than -1, should be 2 itself. These two forms or these two numbers are forbidden. So if I'm going to simplify that one, first of all, factor all of the numerators and denominators like the way they did. Identify all domains. Again, domains is the second step and a very important step. Cancel the common factor and multiply the remaining factors just like the way it was. What about division process? Division is just like the way that we have multiplication, but at this time we have to flip the second term or the second fraction. What does that mean? It means that if you do have something like this, a divided by b divided by c by d, you can convert this one to multiplication by doing a divided by b multiply by d by c. It means that you have to flip this one, and after that do the multiplication and everything would be the same. Right now I do have another step over here that we can call it as the 0th step and follow the same rule. So what would happen if we do have addition and subtraction of this kind of fractions? So if you guys remember from the previous parts, when we had two fractions that if you would like to add them together, you first of all, you have to, if their denominator by the way are not the same, you have to find the LCD or the least common denominator. After that, you have to do a couple of things, but the numerator is still itself, because at the end of the day, we would not like to lose our balance. We would not like to have a new kind of fraction itself. We still want to have the same thing. The only thing that we are going to do right now is just multiply top and bottom by the same number, which at the end of the day is not going to change anything, because if you multiply top and bottom with the same number, those two numbers are going to cancel each other. So we're not losing anything. So the very first important part is that we have to find the least common denominator. We know from the fact that finding the least common denominator in numbers was, first of all, we have to divide those the numbers, for example 24, whatever number that we have, into prime numbers based and related to their powers. For example, one of the numbers could contain 2 to the power 3, whatever. After that, try to find the common numbers with the highest degree or the highest number of power itself, and then multiply it with some kind of uncommon terms. After that, we are going to write down our final fraction, or at the next step fraction, as the way that our two kind of the beginning side of the fractions was in LCD form. Then we have to multiply the numerator also by the same value, because we would like to make sure we're not losing any balance over here. So let me just explain to you step by step, and after that we're going to solve an example. So again, the step over here, we have to factor all the denominators completely. So because this thing is related to the LCD, we are going to do the first work with the denominator itself. After that, we have to build the least common denominator, or LCD, by taking the highest power at each unique factor. After that, we have to rewrite the fractions with the new LCD form, combines the numerator, and after that we do have the simplification. So let's see this very simple example. I do have 1 over x and 1 over x plus 1. So as you can see over here, this guy has only the term of factor of x, and this guy has the x plus 1. So what is your LCD? LCD is the multiplication of all of those. So I have to write down my fraction based on the new LCD. Right now, my first denominator is x times x plus 1, and the second one is the same as well. So what happened to my first fraction and converted to this one? Yes, it was multiplied by x plus 1. So I have to do the same thing with the numerator itself. Why? Because at the end of the day, if you cancel out this one and this one, you still have your first fraction itself. Remember that. So what has happened to the second one? This guy multiplied by x, so I have to do the same thing with x itself. So right now I do have a least common denominator. Everything is okay. I can add this guy up. So I do have 2x plus 1 divided by x times x plus 1. There's nothing I can do for the simplification, yet I have to make sure about my restriction. X is equals to 0 and x is equals to -1 are completely forbidden. At some point it could happen, it's not very common, but it could happen that you would say that the denominator, let's just add them. It is way simpler. No. Least common denominator means that you have to multiply them at this specific point, or some kind of follow another path, which is going to be the same.